In this question, it is told to us that let z and w be two complex numbers such that w is equal to zz bar minus 2z plus 2i and mod of z plus I upon z minus 3i is equal to 1 and real part of w has minimum value. Then the minimum value of n for which w to the power n is real, where n is a natural number. Note that w has to satisfy two conditions. W should be equal to this also, and real part of w should be having minimum value also. First of all, we try to find the value of w, and because the value of w depends upon z, therefore first of all let us see the value of z which will satisfy this equation. This means mod of z minus I is equal to mod of z minus 3i. That is, z is a complex number whose distance from minus I and 3i is equal. That is, minus I is somewhere here, 3i is somewhere here, and I is somewhere here. For this condition to be satisfied, z should be anywhere on this line. I is the midpoint of 3i and minus I, because this line is the perpendicular bisector of the line joining A and B. For any point on the perpendicular bisector, say P, PA and PB will be always equal, where the complex number of the point P is Z. That is, I mean to say, to satisfy this condition, Z should move anywhere on this line. If Z moves anywhere on this line, it surely means that the imaginary part of Z will be always 1. That is, the value of Z will be always in the form of x plus I, where x is this length. That is, we get the conclusion that this condition will be satisfied when Z is in the form of x plus I, where x is any real number. And now let us put this value of Z here. We get W is equal to ZZ bar, that is mod of x plus I square minus 2Z, that is x plus I plus 2. I have put the value of Z in this equation. That is, I get W is equal to x square plus 1 minus 2x plus 2 minus 2i. That is, W is equal to x minus 1 whole square plus 2 minus 2i. It is clear that the real part of W will become minimum when x is 1. And when x is 1, W becomes 2 minus 2i. Hence the value of W is 2 into 1 minus I. And you have to find the minimum value of n so that W to the power n is real. And I have told many times in many lectures that it is very useful to know that 1 plus I to the power 2 is 2i and 1 minus I to the power 2 is minus 2i. This is very useful concept to remember. Now omega to the power n becomes 2 into 1 minus I whole to the power 2 to the power n into 1 minus I to the power 2 whole to the power n by 2. This is equal to 2 to the power n into minus 2i to the power n by 2, and clearly this will become real if n by 2 is in the form of 2, 4, 6, etc. But we wanted the minimum value of n, so that w to the power n is real. Hence clearly the minimum value of n so that it becomes real is when n by 2 is equal to 2, that is n is equal to 4.